All right, here's example number 5 from 10.6. It's another equation where we have two different radicals. We're going to also add a little bit of function notation into it. It says here if g of t is the square root of t plus 5 minus the square root of t minus 7, find any t for which g of t equals 2. So this tells me that g of t equals 2. So where I see that g of t, I can substitute in a 2. So now I have an equation that says 2 equals the square root of t plus 5 minus the square root of t minus 7. I need to figure out what t equals, so we want to solve this equation. But if you notice, we have two different radicals, and they're both on the same side. So essentially what we want to do first is try to get one of the radicals at least on the side by itself, so we can try to get rid of one at a time. So what I'm going to do is I'm going to go ahead and add the square root of t minus 7 to both sides so that I can get rid of this square root of t minus 7. When I add it to both sides, you notice I have something that looks like this. 2 plus the square root of t minus 7 is equal to the square root of t plus 5. So I added the one square root over there so that I can have at least one by itself. So now the t plus 5, the square root of t plus 5, is by itself on that right side. Once I have one of the radicals by itself, I can go ahead and use my principle of power and square both sides. I'm going to square the right side, and I'm going to square the whole left side. When I square the right side, the square and the square root cancel each other out, and I'm left with a t plus 5. But look at the left side. On the left side, I have two different terms, and that binomial is squared. So I can't just distribute the squared. I have to make sure that I write it out twice and FOIL. So I really have a 2 plus the square root of t minus 7 times another 2 plus the square root of t minus 7. Remember on the right side there was that t plus 5. Now we have to FOIL. 2 times 2 is 4. 2 times the square root of t minus 7 is 2 rad t minus 7 times another 2 rad t minus 7. And then when I take the square root of t minus 7 times another square root of t minus 7, remember I have the square root of t minus 7 squared. And the square root should cancel each other out. So I have 4 plus the 2 rad t minus 7, the 2 rad t minus 7, and then just a t minus 7 because the square and the square root cancel. Let's go ahead and look to see if we have any like terms on this side. Well, it looks like I have a 4 and a negative 7. Those are just regular numbers, like terms that I should be able to combine. I have a lonely t that's going to come down by itself. But then I also have these two radicals that have the same exact stuff in them. And if that's the case, I should be able to add and subtract them together. They're like terms. So 2 rad t minus 7 plus another 2 rad t minus 7 is really just a 4 times a t minus rad t minus 7. So I have the t, the negative 3, that's from the 4 minus 7, and then the 4 rad t minus 7 on the left side. On the right side, I still have that t plus 5. All right, I notice that I still have one radical left in my equation, right? And really our goal is to try to get the radicals away. So if I can get them by itself and try to square, then it would get rid of those radicals. I got rid of one, but I still have to get rid of the other one. So let's try to get that radical by itself. Let's go ahead and get rid of the t that's on this left side and the negative 3 that's on this left side. Let's subtract t to both sides and add 3 to both sides. That will get rid of this and so then I should just have the 4 rad t minus 7 on that side. On the right side, it looks like the t and the negative t also cancel each other out on the right side. So it looks like I just have then an 8 on that side, right? 5 plus 3. Okay, from here, my radical is by itself except for that coefficient of 4. What we could do, like we did in the last video, is square both sides. But that would mean you need to make sure that you square the 4 and you square the square root of t minus 7. Really, what that would mean is you would have 2 of these. A 4 times rad t minus 7 times another 4 times square root of t minus 7, which is really 16 times the square root of t minus 7 squared. If there's 2 of them though, they cancel and I'm left with just a t minus 7. That's an option. Or on this one, what I could do is I notice that 8 is divisible by 4. And if the 4 is right next to the square root, then I can get rid of the 4 by dividing. I'm going to do that on this one because 8 is divisible by 4. And so I know that I'm not going to have any fractions like I was in the last video. Do you remember back in the last video, we were at, where were we? At this point right here. If we divided both sides by 2, then that would have left us with a whole bunch of fractions on that left side, and I was trying to avoid that. That's why I didn't divide by 2 on that video. But on this one, I can divide both sides by 4 and not have any fractions. This might be an easier technique. Look what happens. When we divide both sides by 4, I'm left with the square root of t minus 7 equal to 2. It worked out pretty nice, right? No fractions, my numbers aren't too crazy. Now, you can do it either way. You should still get the same answer. But I noticed that dividing by 4 wasn't going to leave me with fractions, and it was going to leave me with nice whole numbers. So I chose this technique. Now, I can see that my radical is by itself. So what I can do is get rid of the radical by squaring both sides. Remember, the square and the square root cancel each other out, and I'm left with t minus 7 equals 4. I can add 7 to both sides, and I end up getting t equals 11. No matter which technique you used, you should have gotten the same answer. Remember, let's always double check our answers to make sure that I don't have any extraneous solutions. So let's take that 11. Let's go back into our original problem, and let's substitute it in and see if it does equal 2. Here we go. I'm going to substitute in an 11. 11 plus 5 is 16. 11 minus 7 is 4. The square root of 16 is 4. The square root of 4 is 2. And 4 minus 2 is 2. So I know that the left side does equal the right side, and t equals 11 is a solution that works. Whew, lots of different steps. Again, make sure that you practice a couple of different problems that have multiple square roots in them or multiple radicals in them. Remember, isolate one of the radicals, get rid of it by squaring or cubing. Get rid of the second radical by isolating it and then squaring or cubing, and then solve the resulting equation. Make sure that you always, always, always double check your answer to make sure that they work in your original